Hello, everyone. This is a talk for deep learning for fun and profit. It's not so much about PyTorch. I use PyTorch. I love PyTorch, but I don't have too much PyTorch in here, actually. A little bit about myself. I think you have seen my face already at this conference. Maybe more than enough. I am a partner and senior consultant for data science at Königsweg. We're a boutique consultancy in Mannheim. I'm also working in the Python community as a program chair for EuroPython, EuroSciPy, so I was quite active this year. So I'm happy this is the last conference I have to work on. One thing I have to mention here, we launched PyData in Frankfurt. So if you're from the Frankfurt area and you want to come around, check it out. We are on Meetup. If you want to give a talk, just ping me. And the next PyData meetup is at the 9th of November at the Tech Quarter in Frankfurt. This is an ongoing talk, so a little bit, real quick, catch up on the story so far. Actually, the first iteration, or the first part, was made for PyData Berlin this summer, how I made my computer write a first story. And I continued at EuroPython with some updates. Both talks are online on YouTube, so I'm going to give you a quick walkthrough, but the extended versions are, you have to check them back online. So, quick update. I really have to rush a bit because there's a lot of ground to cover. The inspiration came from Gene Kogan. Gene Kogan is an artist, and he gave a keynote at PyData London in 2016. And some of you know, actually, my IT and data science, my second career. My first career was in the 90s in the music industry. We were doing techno and house labels, and it was already about digitalization. But that's a story for another time. So, of course, I'm always drawn to art, in a way, and creativity. So I looked at his talk is also online, so I thought, hey, great. Finally, the beginning of the year, I had a project, and I finally could get an eGPU to build experiments on this very computer. If you don't know what eGPU is, there's like Thunderbolt, USB-C, you can plug an external graphic card into a MacBook or another computer, and basically run your experiments locally. This is what I wanted to do, have something local here, and if I need to scale or do something, need more power, move it to the cloud. So this is just like an NVIDIA GTX 1080. It's not yet plug and play. This is, but there's a great source. If you want to look into space, eGPU, there's some great guys that made some great scripts, checking your computer, installing the right drivers, and all the things. Okay. So the first thing after the business project, I said, okay, now I have the equipment, now I can play and explore the space more, especially in the art place. So I started doing style transfer. Who knows style transfer? Okay. So style transfer is, for those who haven't heard about it, learn how basically a painter painted a picture, apply it to a photograph, and create something new. And so I said, well, okay, let's jump in this. And this is a comic. This is a comic I used to read as a kid. When I went to the public library, and I like these French comics. Valérien, Véronique, it's in German. I think it's a little different name in French, but I really love the style and stuff. Yeah, what's it? It's, anyway. Okay, and for example, I love these comics. And so this is like how a modern Flash comics look like. So, okay, it's okay, but don't like the stuff. So I asked myself the question, can I basically learn from this comic back from the 80s and transfer it on a picture like this? And how will this look like? This is my very first experiment. So for those who don't know, we learned from the image, and I squared the learning part, and we learn how it's painted there and apply it here, and this was the result. And I was just like, oh my God, yes, wow. This worked pretty well. And so I was really excited, took holiday photos, pictures I had taken in art museums like this. Yeah, you see the different styles. This is the Flash style. This is like the Valérien style. And then at the left is the original. You can also learn psychedelic styles and apply them to Game of Thrones, the tiger, holiday pictures. Okay, this was fun, actually. You can even apply it to a whole page of a modern comic. And this is all not yet optimized yet. So this was just like very first baby steps. One nice finding on the way was, what about like old and blurry pictures? Like this very old Flash comic from the 50s. I found a really bad scan on the internet. Nice finding, and this is probably also like a useful thing for business and other things. You can really, it adapted the style, but it became readable again. Basically, the resolution is there. Basically, you could almost print it. You can also apply styles to white noise and have like a picture like this. So we learned this style, apply just like to white noise and picture like that. And I sent it to some friends, said, hey, I'm at Tate Modern in London. I just like sent them the picture. How do you like this painting? I really fancy it. And they said, hey, well, yeah, it's a great painting. Yeah. This year we were at EuroPython in Edinburgh, and this is like a very famous picture. Like this is, if you see a lot, if you see Edinburgh, this is Edinburgh. And I just tweeted it to announce my talk at EuroPython about the same talk here, like the previous version. And I just thought, okay, I just wanted to like promote it. And then somebody said, okay, I took this picture, and I said, okay, I thought it was an attendee, knowing about the domain, and I said, oh yeah, it's a reality transfer, and he just replied, no, it was a picture, I took it a few days ago, and I was wondering, when did you draw the painting? And I just replied, no, it's not, I didn't draw it, it was made by artificial intelligence. And then said, oh, I see, even more amazing. And of course, you can just like go to a conference and do your own comic. Once you have trained the model, it's really fast to apply. So, and you can even like have a whole comic. Once upon a time in October in Karlsruhe, can enter, like you see Peter and Sebastian here, and you see conference organizing is fun, the pretzels, you see stickers, and all the stuff, and quite unbelievable. And you can have like, yeah, you can like document the whole thing. Here. I didn't really build a story, didn't have time for that, but this is just like this morning. So I'd taken a picture from a tweet, and then we just have Veskining's keynote here as in a comic style. Okay. The technology, like local CPU chip, ability to the cloud, and another big issue was reproducibility and documentation of the experiments. When I just like played around, I didn't document a lot, like random seed, parameters. I was just toying around, and I think for the part is fine. But then I had, I saw, okay, we need documentation. I want to reproduce my experiments, because if I cannot explain why something works or not, that's really bad. So, but you have to look at the other talks for that. So this is all now solved. So you can imagine I got a little overexcited with like the style transfer, because everything was just like amazing. I felt like this. And so I thought, okay, I very often don't have the possibility to present a real use case from a customer. So how can I deal with that? So what can I do to give you something of value, something which is close to real life, and to explain stuff, and to say, basically turn around, say, okay, here's a challenge, and now we're going to throw deep learning at it and see how far we can get. So it's not just, okay, we have this tiny thing and we can solve it probably with deep learning. So let's say, okay, let's take a full product and try to fully synthesize it. And of course, I was also drawn back to the days when I was a child. So I thought, what about, them? Who knows them? Who knows what it is? Oh, yes, Germany. Who doesn't know? This is like die drei Fragezeichen. It's the Three Investigators in original. It's a book series from the US. It's like a teenage detective in mystery crime stories. It goes back to 1986. It's not really popular in the US. I think it's only popular in Germany. But in Germany it's very, very popular. And so there are like 200 taped radio dramas. Hörspiel. Who knows Hörspiel? Okay. Okay. Everybody, I think this is all the Germans in the room. Okay, there's like 200 tape radios. I'm going to explain them in a second. The radio dramas have sold more than 45 million copies over time. This series is going now for 40 years plus. So I thought, okay, eventually the people to speak the recordings will eventually die. So maybe it's time now to get into deep learning so we continue the next 40 years. Okay. A little bit more radio dramas. Hörspiel. What is that? Taped radio dramas goes back pre-television. No, pre-internet. Pre-television. We're now like in the 1920s. When people are having radios, and what is a tape radio drama? It's basically a movie without pictures. So people were just listening to the radios, and you had actors telling you a story. And very famous, and if you don't know it, I can really recommend looking into this. One of the pioneers was Orson Welles. You see, like 23-year-old Orson Welles in the 1920s or early 30s, I'm not sure. He made a radio drama, and not only a radio drama. He made the radio drama like a documentary, and about aliens invading the United States, and people were panicking because they thought it was real, because the whole radio media thing was pretty new. So. Really good. It's great. So this is like a news article here. So how does the drei Fragezeichen look like? So we have like the drei Fragezeichen in the flüsternde Mumie, and sounds like this.
Ihr würdet es mir nicht glauben, wenn ich es euch vorlese. Ihr würdet glauben, ich spinne. Wie kann eine 3000 Jahre alte Mumie flüstern? Er ist der Ahne des Hauses Hamilton. Vor 3000 Jahren kamen Könige aus Libyen nach Ägypten, um das Land zu regieren.
Yeah, okay. Here. You hear how it sounds like it's more like a teaser. You see it's like, this is a script. Luckily I found scripts on the internet. Like they were handmade by people. So this was really good. And this is basically how the artwork looks like. And who's an expert would already say, hey, Alex, there's at least half of them are fake already, but more on that later. So, okay, which are the ingredients to be synthesized? Actually, the story, the plot, what's happening, the dialogues, it's very dynamic human speech. People are interacting. We have to have the artwork, a cover, just as I showed you, and we need spoken word and something to synthesize it. And now we're going to look into the different areas. Not all are covered yet, because there's quite a lot of ground to cover, I realized. So, which resources are required for each individual step? Choosing the right AI or neural net for that, data acquisition and processing. What are the costs and time? Because I'm a business consultant, so I have to advise my customers where to spend their money. So how much money and effort have to go into each of the single steps? And which real problems can we potentially solve and find on the way, because experimentation in AI is something that is really an important part as well. Okay, so let's go to the generalization. So we had transcripts. We're still like in the upload slide. Extended versions are online on YouTube. The technology stuff, we covered it. The process is very important. I always take the same process for each and every step. Data acquisition, data cleansing, research a paper and a working solution. Verify it's actually working. It's not somebody just writing the next blog post. And adapt the solution for the specific use case, and then go to maximizing quality. And we're going to, so always like the very essence of this is always only exchange one variable at a time. So you can see if something's not working, you can investigate what is not working. And I think this is one of the probably the best advice. Never change more than one variable and stuff like that, because it's hard to figure out. What's next? So, fabricate text. Who knows Andrew Carpathy's blog post, The Unreasonable Effectiveness of Recurrent Neural Networks? Okay, 20%. Okay. So, Andrew Carpathy is a really bright guy. He wrote this blog post a while ago. It's a really readable and very nice blog post, and he explained how we can use RNNs for text generation. So he learned on Shakespeare sonnets, and to train the model for Shakespeare sonnets, and then created new Shakespeare sonnets. And this was very impressive. This is like very often quoted. He was in his PhD, and now he's, I think, chief data scientist of Tesla or something like that. So really great. I really can recommend reading it. The link's down there. So the process here. I found fan-made transcripts, which was great. So I have the text. I pre-processed them. I also identified the characters via some fan wiki, so to identify who's actually speaking, to match names to text. And the total text corpus is 1.5 million words in the German language, and 56,000 are unique. This is an RNN. This is how it works. I don't want to go deeper here. And I just the question was, is this text corpus big enough to produce something? I mean, it sounds like a lot. Oh yeah, it's 200 radio dramas. Is this enough to produce something in the German language? And let's see. And this is some stuff the neural network actually produced in German language. And below is a Google Translate, which is actually quite accurate. So you see, okay, yeah. I probably can sell this as German to many people around the world, but not to Germans. I really like the Schlokolianer, actually. That's a really nice word. But you see, okay, it sounds German, but it's not really something useful. So you can, of course, also use it and send other stuff to your friends. Yeah. Okay. I settle for character-based. So actually, we're learning on the network predicts what's the next character. They're cooking at the characters. We use this because it's a lower space in matrices, because there may be only 30, 36 characters to cover. We can also try it word-based, which of course is a lot more to compute because we have 56,000 unique words, and it came up with something like that, which is also really nice and funny. Okay. Wasn't quite as expected after my style transfer, but we had fun. Okay, so I thought, is RNN the only solution? I came up on a lot of stuff during my research for this talk, and so I also, what about chatbots? So, and I read about, there's somebody who took Star Trek Next Generation transcripts and built a Picard, Worf, and all these chatbots. And I thought, let's see how that stuff works. Because reading the blog post was really, awesome stuff. So I tweeted to Captain Picard. Actually, I took one line from the real transcript to make it easier for the neural net. So I threw something at the neural net, which the neural net actually should know, but actually, it was just noise and, fights and beams, and it was not really fun. It took me a week to get rid of answers from Wolf and data and stuff. So, okay. So text was not nice. So, of course, deep learning now is the new kid on the block for 3 years now. So it feels new, but of course, I just looked at my bookshelves. All this stuff you can probably see for the covers. The problems are not new. The problems and deep learning and neural nets, they go whack, bay, whack, go, bay, whack. They go back to the 60s, 50s even, with the same problems. It just woke up again. Next challenge, text, let's put the text to sleep it over a little bit, maybe I can come up with something better. The next step, artwork. Artwork, we use a CNN. So we basically compare two pictures, and basically the neural net and take smaller parts of the picture, and the neural net can actually learn how a certain style. For example, from the original paper, Tübingen at Night with Van Gogh style. So I tried that. We probably know already from my introduction this works well on many styles, but can I also have it learn on something on the style of the three investigators, because they have a very specific style. It's not just Van Gogh style, it's over the years styles have evolved, and you can now take a quick guess, 50% are fake. Which ones? 3, 2, 1. These are actually fake. They are fabricated. I just choose a picture and throw in some art styles I'll have learned on the three investigators there. So this is fun. Actually, the seltsame Wecker was very obvious because this is like super classic. So, okay, really nice. So we can fabricate some artwork, I guess. So there's also some stuff people on the internet will probably not tell you, or mostly they only talk about stuff that works well. For example, like I had a data set of pictures, like 30 pictures, to see how the network was learning. So I always like build a nice set of different pictures to see what's going on. For example, this picture hardly ever worked on any style transfer, which was quite, so it's not always working. You can reason about why this is not working. Well, have to check that on video. Of course, it's really nice to impress you with stuff like that, but we also have to see there's a lot of stuff like that and even worse while training and doing the stuff. So it's not just like throw something with deep learning and magic. No magic. It's just linear algebra. To sum all my findings up, Ned Radcliffe is a very bright guy. He talked about quantum computing at EuroPython. He put it this way. Okay. Yeah, well, now the updates. I've looked more into the speech space. How can we fabricate speech? So basically send text to a model and have it basically talk to you in a human-like voice. This is the network. It's tachytron true. So basically, the idea is we learn from MEL spectrograms. MEL spectrograms is basically how we say something. So it's like a very rich spectrogram. And then we try to learn it, predict it, and align. This is like how the two are aligned. And if you see a straight line here on 45 degrees, it's really well aligned. So let's look into that. So training the network requires audio snippets, text, and the text. So I found a really nice data set of 24 hours recording by this one female speaker of 24 hours of non-fictional English data. Prepared, cut, really nice data set. And I had it learned. And now the network will always read this first sentence to you. A little louder, please. Okay, you see like after 10 hours it's like starting to blowl. You see something in rhythm happening, so it's okay. It's not probably useful. After 14 hours. Okay, after 5 days.
Once upon a time, there was a little merman named Siren who lived with her stepmother under the sea. He didn't get to go out of the sea like any other.
So actually I was quite impressed.
Once upon a time, there was a little mermaid named Siren who lived with her stepmother under the sea. She didn't get to go out of the sea like any other.
This is something I did not expect. Having a nice data set, throwing tachytron true network, and producing these results within a few days. This was, I think, quite amazing, because you have to consider, I found the data open. It's an open source data set online. I found a nice and really well-coded GitHub repository from NVIDIA for the network. And, actually, this is a low budget project. I mean, this is maybe like 3 days, 4 days of work. For me, and basically $50 for computation or something like that. So this is like super cheap. So this is quite amazing. So of course the next question is, let's do this in German, because if you throw German at this network, it doesn't sound that good. Okay, so how can I get snippets in German? Okay, that's not too good because there's no open data sets in German, only few, and I couldn't really use them. So, okay, I have to fabricate them. How can I do this? So, task building a German corpus to learn with, audio snippets, text. From the audio snippets, options are audiobooks or newspapers where people read you the newspaper. So I said, okay, that's a requirement, but I have a requirement for humans to prepare the data set. So I asked my business partner, Zir, can I have like 2 working students for maybe 2 months to produce the snippets for me? Zir said, hey, Alex, I really like your talks, but no. So I had to come up with something smart. And this is the other thing. Neural nets don't solve all the problems. You have to think. So I started thinking. I said, okay, I have the newspaper, so I scraped the text from the website of the newspaper. I have the audio version. Somebody read that. I used a cloud service to transcribe it. So the transcription sends like a JSON and with a timestamp when actually the word was spoken. So I can use some heuristics and the word time index to produce audio snippets and the text from the snippet. This worked quite well, actually. So I produced a set, but there were also some assumptions because you listen to all the stuff. And even like you saw, like Wes just said in the keynote, Google is throwing billions at TensorFlow. And if a company throws millions at something, there's an agenda. And the same is with Google and cloud services and what they probably want to make you believe. The transcription services are really good, but how many transcription services are there available in German? There's a guess. Amazon? Raise your hands. Amazon? German? Oh, you're all so well educated in this space. Okay. Let's shorten it a bit. I thought, okay, Google, I was doing it with Google. The transcription was okay. Basically, it catched what was said, but it was not the word spoken. So it was okay. Quality is okay, but I had to use a lot of heuristics to make the matches. And I thought, okay, maybe I can find another service even cheaper. So I checked Azure, IBM, AWS, Offline, Python Labs, and Apple. And there's only Google for German. There's no service on Microsoft or IBM or AWS, and Siri is only if you use an iOS device. Okay, so that's not so simple, but I solved it. I had a newspaper article read by 25 speakers. Okay, I think we all got that. And now we first listen to the original. So this is an original text taken from the newspaper.
Deutschland darf kein Talent vergeuden, so heißt es immer wieder. Wo aber bleiben in unseren Schulen die Angebote für die besonders Talentierten?
And now we're listening to the neural net trained after 14 hours.
Deutschland darf kein Talent, das heißt, das Sinn ist, es ist
You see, but I think it starts blabbling. You see there's a rhythm. It sounds human, although also scary. My partner was scared. He was listening next door. Stop doing this, Alex. I'm really scared. But after 10 days.
Deutschland darf kein Talent vergeuden, heißt es immer wieder. Wir bleiben in unseren Schulen die Angebote für die besonders Talentierten.
Yeah, so it's picking up. You can even recognize the speaker, which was, I think, also quite amazing. The data set is still not super perfectly cut, so it's working. Also another side note. After 14 days, training longer is not always for the better. That's another thing you have to consider. So, but I think that was quite cool. So the challenges, lessons learned here. The assumptions were neural networks are hard to set up. Neural networks are hard to train. Neural networks are hard to understand. But neural networks are smart. This is when you look at stuff online. Neural networks are. Data is like the new oil. We have heard this for quite some time now. And there's genius people like Ray Kurzweil claiming singularity is coming in 2045. And it's not like a black hole. It's like AI is more. It's smarter than humans are, and let's check into that a bit. First assumptions: neural networks. We have seen it. Did I tell you about any trouble setting up the neural net? The biggest troubles were actually bad Python code published on GitHub from smart people, actually, and big companies. So I found stuff published by Facebook just recently, something really hot everybody wanted to look at. But I said, hey, it's Python 2.7, guys. Python 2.7 is going to die next year. So why start anything new in Python 2.7, guys? You see a lot of Jupyter notebooks. You see a lot of closures, people using variables within functions, and the function is somewhere defined at the top of the notebook. So 5 pages later. So that's not really readable. It's also not transportable. I mean, okay, it works running the Jupyter notebook. It might be nice to prove something, but it's not good coding practice. Also, like using input or list as variables, because pathonistas, you all know, it's not a good practice, but you see that a lot. Okay. So neural network was the network, except for learning which networks are good for which use case. This was all I had to know about networks. And then choosing parameters and stuff, there's always libraries to help you with that. So the network actually was not the problem. Unexpectedly, because it's the magic, the black magic part from the outside. They are not hard to train because it all depends on the data. And I think they're also not smart if we look at this. For example, this is the Google Translate. And if there's people who actually have the hobby at it, I'm not one of them, I just found this online. If you choose Somali, throw a lot of "ak" at there, it will translate a real sentence. And I think, but this is a very good example to understand how networks actually work, because they're not smart. You just found a nice spot of correlations. They said, oh yeah, there's many "aks," and "ak" is actually a word in Somali. And it comes to something like this. Also, where does this text come from? People were claiming, oh, Google, do you use the Bible to learn from? So no, we don't do that. But actually, I don't believe them, because is this even documented on what Google Translate ever learned translating Somali into English? I don't know. Maybe not. Because this is not going on since yesterday. It's like 10, 15 years. I don't know when Google Translate started. Networks are easy to fool. I found this, which is, I think, mostly entertaining. So here you see, if you don't know the MNIST, who knows the MNIST dataset? Okay, half of you. The MNIST dataset is something you very often use in beginners training. So basically, have a network learn how to read handwritten numbers. And something, Emilian just wrote this blog post, and he just put a chicken here. And basically the network was very sure the chicken is a 5. So it was not, I don't know, maybe 10%, most likely a 5. No, it was like more than 95% sure. It's 99.9% sure it's a 5. So networks are easy to fool as well. Another nice example is here. On the left side, we see a panda. The network says I'm 57% sure it's a panda. Then we put some noise in there in the picture, and the result is 99.3% confidence. This is a gibbon. Okay. And this is something we don't see as humans. It's also like one of the big challenges if you talk to people building cars, autonomous cars. How can we prevent people fooling our autonomous systems with stuff like that? Or like something lights and stuff. So because these networks don't work as we humans do. They are very different. The next assumption is data is the new oil, and I would claim these people are rather right, because oil is limited, data is not limited. There can be more data than atoms. So I put 2 here, you can look into it. I think we should also rather think it's the new nuclear power without the waste, hopefully. Yeah. Okay. And if you look at how much, what was the expectation if you start with neural nets? The expectations like that, we have the data anywhere, they're easy. Okay, we build some pipelines, then we have a huge network problem. So you see here, this is like the expectations many people have on how much resources are required to get the network to do something with deep learning. So, yeah, the data's around anyway. We have some pipelines. The network is a big problem. And then applying and serving the models. Yeah, once we have the models, they're easy to serve. And I want to go, but this is like a good machine learning development example, but yeah, read it later. We'll show on time. Reality shows, and also everything I did was, what was the biggest problem? It was always like having nice, clean data and having them in the system. The network, actually, I can just take it from a research paper, because there's, of course, building a network, experimenting with networks is also like a lot of work. But we don't have to look into that, because there's many great scientists publishing their work, and we can just basically build and continue what they produce and openly make available to us. And I'm really grateful for that. So, but for me, from the perspective, building something with deep learning, the network was never a real problem. But serving the models, serving models, updating in production is a problem, and many people, and there's a lot of talks about this as well. So the perspective is totally different. It's not the magic AI network, which is the challenge. It's the data mostly, and having models in production. Apart, there's also other problems or things you have to consider. Ethics, because once we have something in a network, you can have also look into, okay, is it discriminating anyone? Is it like not only from humans, but also like, are there some assumptions which are just self-fulfilling because the network has learned on data? There's also like a lot of talks on that. Just go to pyvideo.org. There's a lot of talks about this on Python conference. I think a very good read is this from Rachel Thomas from Fast AI, and she's writing what do machine learning practitioners actually do. So she wrote the post. What is the work? It's like a 3-part blog post. It's like maybe 1 hour read. And I think this is really valuable input. It's also like a little bit opinionated because she also says, okay, why is the CEO of Google, like in the Google conference, announcing, yeah, TensorFlow, deep learning, all this. Yeah, we have to also think about it. Yeah, Google also like sells cloud computing. So stuff like that. There's a really good read. I have this is like the German version, so German readers read fit real quick. There's an English version coming. It's an interview with Margaret Bowden, which I can really recommend. It was in the Zeit magazine recently. Margaret Bowden is actually she studied psychology for 50 years ago, and she started for experiments to look into the AI space. And she was giving into it. She wrote a lot of books on the whole thing. And this is like the translation. And she said, okay, many think there's like this superhuman artificial intelligence is near and coming. For example, Ray Kurzweil. Do you believe them? And she says, I ask him. I value him. They know each other. They do all of this like for 40 years. They're like this. And he really believes it, she says. And what do you think? I think this is all, I mean, I really value his work. He's a genius. She says I would not label many people as a genius, but he's just like crazy, and the prediction is crazy. And this is basically all the media buzz is about. And this is also, I have to point out, because this is also something, if you're in the AI and deep learning space, you have to point it out, because there's a lot of stuff like this going on. I really had to think about what to do about this tweet from Zemans. Because it's like a sponsored tweet, and you see like a nice movie. There's Uli. Uli is working with his team at the Virtualienmarkt in Munich, like Center City, super top spot in Munich. He's working there and teaches, and with his team, he teaches machines to think. I said, well, no. Who came up with that? So, and I really thought, should I comment, should I not? So I came up with this. I said, machines don't think, sorry. Machines, work, but they don't think. Maybe Uli want to explain this to his Siemens colleagues in marketing. And actually, Uli saw this tweet, he replied, he said, yeah, you're right. We do software and we implement this. But this is like one of the biggest issues in the public perception, that AI is not an android, it's not human-like, it's super specialist on very specific tasks, as something to consider. Maybe this is not easy to sell to a customer, but actually when we talk to customers, we always have to say, okay, yeah, we have read all this great stuff, and there's like all the ideas we have in our mind from Hollywood and movies and marketing and people who don't have a clue about AI and deep learning, making all these assumptions and putting all these pictures in your head. And usually it takes some time to really get, okay, this is what you can do. There you can apply, and you don't really have to worry about your workers getting unemployed. Because maybe they will just move to a different space, and we have some awesome tools. So the summaries are neural networks great and useful? Of course they are, but we have to give it in the right perspective. This is an ongoing talk, so there's going to be constant updates. But most of the conference talks will be published. I'm quite surprised. We even have 5 minutes for Q&A left. And if you have, thank you. We have 5 minutes for Q&A. If you have any questions, we also have a booth here. Königsweg is one of the community sponsors of this conference. Just come, talk to me. We're also hiring. And if you want to have a comic version of your picture or any picture, I can also happily provide it to you if you want. Okay. Thank you very much.
Thank you very much, Alexander, for this great talk. We see pandas and noise are givens. So, first question.
Yeah. Thanks, Alex. Do you know the Prisma photo editor?
The what?
Prisma photo editor.
Yeah, I know it. Yeah.
And the other one is also for videos already. I think it's Aristo or name.
Yeah, there's some apps who use this technology and style transfer.
Same technology?
It's the same technology.
Server-based? Yeah. What do you think about this? We can comment on these apps.
Actually, I've never tried them in depth, but I know friends who use them. So it's there. I mean, it's for a while. The style transfer paper, I think it was 2.5 years ago. I think what I probably didn't point out today is how to judge what is good or not, because we were quite impressed, probably from the fabricated voices, which were not production ready, but easy to say. But we also have, and also the text. Actually, artwork is way easier to fabricate because there is no definition. I can tell you this is a wrong German sentence with grammars and stuff. So you have to be way more accurate. And basically, I can throw any painting or many paintings which look like something to you, and you said, yeah, it's art. I mean, the space is open.
Thanks.
Yeah.
More questions?
Thank you for the talk. My question is, how much do you think of the style transfer is actually cherry picking?
What again?
How much is cherry picked? How many of the examples we see?
I didn't really count, but I just saw a lot of papers on GitHub, and my intuition just alarmed me. You always see the same examples. So of course, you have to look. A lot of stuff is published by students who put some work in it. And probably they just have some simple goals. Maybe they just want to share their work. They would just want to see this works in another library. So I don't want to really judge them for doing this, because still they provide something and they're to free knowledge. But the thing is, and it's also more a general problem, I also see working on the conferences, it's way harder to make people talk about problems and stuff that is not working. For me, this was also a big issue, because I had these results, especially in the text space. Luckily, I know a lot of experts who I can ask, okay, these are my results. And I said, yeah, that's okay. Even people working full time have similar results, especially in the German space, because, for the text. So I can, if you work in this space, I just can encourage you, in any space, also talk about stuff that is not working, because it's usually more helpful than the glamorous stuff for your people listening to your talks. Yeah.
More questions? So I do have one question. If no one.
No, there's no Geo AI.
No, that's no problem. I was wondering about the eGPU you mentioned at the beginning.
Yeah.
How hard is it to set one up? Is it worth it?
Oh, actually, my main problem actually was PyTorch. Because PyTorch and eGPU, you have to compile it on the Mac, and that was the hardest thing. For example, if you use a Linux machine, you have a wheel. You can just install it. On a Mac, it was a little problem. Also, you have to be aware the commits. The PyTorch is moving all the time, but the commits go to the master. And I had versions compiling, and then I did an update, got the newest versions, and stuff was failing, because also PyTorch is a very complex concept, very complex project, and some other libraries, I think Caffe, were actually not compiling. So it was not actually PyTorch, but something PyTorch users made the trouble. So I checked the right commits. But I'm not sure because PyTorch 1 beta is released now. I think maybe even on the Mac you can get a compiled version. I know it is on the agenda, but if you want to hear more about the latest stuff in PyTorch, Adam Patzke is speaking here at 2:00. He's one of the core developers of PyTorch. He can tell you all about it.
Okay, great. Thank you very much again.
Thank you.